अच्छा जी, today is 12th January and it is our first class of unit number 2. And in this unit number 2, there are four main topics to study: electricity, wave superposition, light, and quantum physics. So we are starting with current electricity, unit number 2. What is current electricity? So we are starting with the knowledge of IGCSE, and then gradually we will increase the difficulty level. But the starting theory is the same. Sir, what is the theory? My theory is, consider this is a metal rod and all the metals are good conductor. And why are they good conductor? Because they contain free electrons. And if the metal rod is not connected with a battery, then obviously these free electrons will be moving in a random direction. But when you connect this metal rod with a battery, then obviously all these electrons begin to flow towards the positive terminal of the cell. And when electrons begin to flow, then this flow of free electrons, it is electric current. So what is electric current? Electric current is flow of free electrons. It is called electric current. But in physics, it is not allowed to use the term free electron in current electricity, and we change the definition by replacing free electron to electric charge. And in IGCSE, you have studied the rate of flow of electric charge, the rate of flow of electric charge is called electric current. And you know, electric current is denoted by I. And in IGCSE, we have studied rate means, sir, divided by time. And this is the rate of flow of charge. So its formula is Q upon T. Q for quantity of charge divided by time. So it is our basic formula, I is equal to Q upon T, whereas Q is the charge. Q is charge. But you know, the the minimum electric charge is equal to one electron charge. And this E stands for elementary charge or charge of one electron. But if there are two electrons, then total charge will be 2e. If there are three electrons, then electric charge will be 3e. And if there are n electrons, this capital N in current electricity, it represents total number of free electrons. Total number of free electrons. So in many questions, they will ask, calculate number of electron. If they ask to calculate number of electron, then we will use this formula. I is equal to Ne divided by time. Ne is the charge, T is the time. So I is equal to Ne upon time. So it is its basic formula. Then you know the unit of current is ampere. And beta Simra, do you know what is the unit of charge? What is the unit of charge, beta? No, no, unit of charge. No, no, unit of charge. बनी याद है? अच्छा, unit of charge is coulomb. Unit of charge is coulomb. Okay, so unit of charge is coulomb. Unit of current is ampere, and whenever we have to measure current, then we use a meter, and this meter is called ampere meter or simply ammeter. So ammeter is used to measure electric current. Ammeter is used to measure electric current. So this is the basic formula. And now, after completing this concept, okay, what is the electric current? Actually, electric current is the flow of free electrons, but we cannot use term free electrons, so we say it is the rate of flow of electric charge as well as the direction of current. The direction of current is assumed that current flows from positive terminal to negative terminal. In current electricity, the direction of current is considered current flows from positive to negative terminal, and this direction of current is called conventional current. So if I say the current is conventional current, then you should use this direction. Okay, conventional current flows from positive terminal to negative terminal. Conventional current flows from positive terminal to the negative terminal. So the current electricity topic is completed. And now the topic is, sir, why electrons flow? Why there is a electric current? What is the cause which produces electron to flow? So the answer is, sir, voltage is the cause. Voltage is the cause of electric current. And you know, voltage is not a physics term. It is not a physical quantity. The proper physical quantity is either electromotive force or potential difference. But in general, we can use EMF or PD as voltage, so it is okay. But the proper term is either EMF or potential difference. And the question is, sir, what is voltage? What is EMF? What is PD? So now I am going to explain. The explanation is, sir, when you connect a conductor with a battery, then before connection, electrons were moving in a random direction. But when they are connected with a battery, then this battery provides energy. This battery or cell provides energy, and this energy is responsible to drive free electrons. This energy is responsible to drive electrons. And you know, we can use energy, we can use the term work done. So the proper definition in the textbooks is, so the work done per unit charge. The work done per unit charge. The energy which drives electric charge, the work done to drive electric charge, it is called voltage, it is called EMF, it is called PD. And when we solve the questions properly, then I will especially differentiate what is the difference between EMF and PD. But simply I can say, sir, EMF is work done per unit charge at source. The source generates electricity, and work done per unit charge at source, it is called EMF. Whereas the work done per unit charge on load, the work done per unit charge on load, it is called potential difference. So it is the measure difference. Potential difference term is used at load, and EMF term is used at source. And you know, at source, electricity is produced. You know, electricity is produced. Whereas at the load, electricity is consumed. So I can say work done per unit charge to produce electricity at source. It is called EMF. The work done, energy supplied. Work done to produce electricity at source. It is called EMF. And the work done per unit charge at load to consume electricity. It is called potential difference. So it is the main difference, but I know in your exam they do not ask to differentiate between EMF and PD. You should only know, sir, potential difference, basic formula or basic definition is work done per unit charge. Work done per unit charge. And you know the unit of work is joule, the unit of charge is coulomb. So the unit of potential difference is volts. That is why voltage is measured by voltmeter. Voltage is measured by voltmeter. So we have completed two basic definitions. Definition number one, what is the electric current? Electric current is the rate of flow of electric charge, and voltage is work done per unit charge. So you should at least memorize these two basic definitions. Work done per unit charge is voltage, and rate of flow of charge is called current. Voltage is the energy supplied by battery to drive electric charge. It is called voltage. बेटा बनीन आपकी क्लास में हो क्या? बनीन आर यू इन क्लास? बेटा ठीक है ठीक है बेटा बनीन मैंने दो डेफिनेशन इतनी देर में समझाई है क्योंकि बीच में आप ड्रॉप हो गई थी. एक तो इलेक्ट्रिक करंट, ठीक है ना, करंट होता है रेट ऑफ फ्लो ऑफ चार्ज. और दूसरी डेफिनेशन वोल्टेज, सर वोल्टेज होता है वर्क डन पर यूनिट चार्ज. ठीक. वोल्टेज is a cause which drives current. Okay, so we have discussed these two basic definitions, and now we are starting the relation between these two quantities. And you know this relation in IGCSE, it was Ohm's law. So today's third heading is Ohm's law. What is Ohm's law? So Ohm's law is current is directly proportional to the voltage. Current is directly proportional to the voltage. If the voltage is high, there will be greater current. If the voltage is low, there will be small current. You know, at our home, we are supplied voltage by electrical company. It is very high voltage, 240 volt. And if by mistake we touch an electric wire, then we experience an electric shock because voltage is high, so the current is greater, so it can give you electric shock. But if you use a mobile charger, you know, mobile charger or adapter having very low voltage, 6 volt, and if you touch the wire of a charger and switch on the electricity, then the current is very, very small. Okay, you cannot experience this current. So it shows if the voltage is high, there will be greater current. If the voltage is low, there will be small current. So current and voltage are directly proportional. And when you remove this sign of proportionality, then we use a constant capital R, and this R is known as resistance of conductor. This R is known as resistance of conductor. And we will discuss properly what is the resistance. But right now, as we have discussed, sir, current and voltage are directly proportional. So, beta Banin, can you tell me if the two quantities are directly proportional, then what will be the shape of the graph? Banin, beta, दो quantities directly proportional. हाँ बोले बोले. G, there will be a straight line which is passing through origin. Okay, number one. Number two, sir, Ohm's law remains valid with a condition. And the condition is if the temperature is constant, then graph is a straight line. If the temperature is constant, then graph is a straight line. Okay. But if temperature changes, for example, you have a filament lamp. If you have a filament lamp, then you know filament lamp becomes hot. When you increase current, it becomes hot. Its temperature rises. And when temperature rises, its resistance will also increase. And when temperature increase, then obviously now the filament lamp will not obey Ohm's law. And if it not obey Ohm's law, then obviously graph will not be a straight line, but a curve. But a curve. And this curve is bending away from current axis. This curve is bending away from current axis. Right now, I have plotted current along x-axis, but it is possible. Sometime you will be given graph in this form, and you can see the current is along y-axis. If the current is along y-axis, then the curve again bending away from the current axis. So do not memorize the shape of the curve. You should memorize the concept. If temperature increasing, if resistance increasing, then the curve bending away from the current axis, and current may be along x-axis and it may be along y-axis. And one more thing in your A-level physics, one more thing in your A-level physics, which we do not study in IGCSE. If the temperature is constant, then the graph is a straight line, and you can see the graph is passing through origin, and you will draw graph in first quadrant as well as in third quadrant. Sir, what is the meaning of third quadrant? I am explaining, but you should note down first. The current and voltage graph you will draw in first quadrant as well as in third quadrant. In the same way, in the same way, for filament length, for filament length, the curve is bending away from the current axis as well as here is the current, so it is bending away from the current axis. So the graph will be like this. Graph will be like this. So you have to draw graph in first quadrant and in third quadrant. Question, sir, what is the meaning of third quadrant? I am explaining. First, you should note down. Jupiter Simra, have you noted? Okay. जी जी मैं दोबारा अच्छा स्क्रॉल कर तो ऊपर की तो कोई बात नोट करने की जरूरत ही नहीं ना आप ये वाला बना ले ये तो वैसे ही कंप्लीट है ये तो बेटा कंप्लीट ग्राफ है ना ये तो कंप्लीट ग्राफ है कंसीडर दिस इज अ फिक्स्ड resistor and this fixed resistor is connected with a cell or a battery. Consider its graph we have plotted in the first quadrant. Okay, sir, if we switch the polarity, if we switch the polarity means Initially, it was positive, it was negative, but now it is negative, it is positive. When you switch polarity, when you interchange plus minus, then the graph, then the graph is plotted in the third quadrant. Then the graph is plotted in third quadrant. अस्सलाम वालेकुम बेटा अब्दुल्ला. अच्छा बेटा अब्दुल्ला, आप थोड़ा सा लेट आए हो ना, तो इन बातों को पढ़ने में अभी थोड़ा सा वेट कीजिएगा, फिर मैं आपको समझाता हूँ दोबारा. ठीक है बेटा. अच्छा जी, नाउ वी आर मूविंग फॉरवर्ड. दिस इज graph of length. In IGCSE, beta Abdullah, you have already studied this graph. If temperature is constant, then the graph is a straight line. If you are studying filament length, then it is a curve. And these two curve I have added. And now I am adding one more electrical component. Beta Simra, do you know this electrical symbol in IGCSE? What was this? Do you know? This is resistor. Okay. But the first thing which I have drawn, what is this? बनीन तुम्हें याद आता है ये जो ब्लू कलर की मैंने ड्राइंग बनाई है ये क्या है? जी, you are right. Sir, we have studied in IGCSE. This is diode. This is diode. Okay. And if the positive terminal of cell is connected with positive terminal of diode and negative terminal of cell is connected with negative terminal of diode, then this diode is connected as forward connection or forward biased. This is its proper name. When diode is connected in this way, then this is called forward connection or forward biased. And when a diode is connected forward biased, when a diode is connected as forward biased, then consider here is voltage, consider here is current. This diode graph was not in IGCSE. This diode graph was not in IGCSE. Okay. So diode graph in A level is this. When you increase voltage, consider the voltage is very small. At very small voltage, no current through diode. Sir, if we increase voltage, sir, no current. If we increase voltage, sir, no current. But at a certain voltage, now diode is ready to pass current. And after this certain voltage, diode starts passing current. So the behavior of diode is this. If you apply very low voltage, then diode does not pass current. If you gradually increase the applied voltage, then at a certain voltage, then it starts passing current. So the graph is like this. As well as if you interchange the polarity of battery, consider this positive and negative are interchanged. Consider this is positive, this is negative. Sir, if you reverse the polarity, now diode is called reverse bias. And when diode is reverse bias means you can see, sir, minus connected with positive and positive connected with negative, positive with negative, negative with positive. Then this is called reverse bias. And remember, in reverse bias, diode cannot conduct current. In reverse bias, diode cannot pass electric current. So left hand side shows reverse bias connection and right hand side shows forward bias connection. So in this way, I think we have studied enough, and I am making a summary, and then we should solve some past paper questions. We should solve some past paper questions. बट अब्दुल्ला, मैं आपके लिए रिवाइज कर रहा हूँ, गौर से सुनना बेटा अब्दुल्ला। अब्दुल्ला, आईजीसीएसई में आपने पढ़ा हुआ है इलेक्ट्रिक करंट इज डिनोटेड बाय आई। बट अब्दुल्ला, आर यू इन क्लास? ठीक है अब्दुल्ला, करंट इज डिनोटेड बाय आई एंड द फॉर्मूला ऑफ करंट इज चार्ज divided by current, sorry, charge divided by time. And if you have to calculate charge, then charge is the product of current into time. अब्दुल्ला जल्दी से ये फॉर्मूला कॉपी करो। फॉर्मूला नंबर वन, current is equal to charge upon time and charge is equal to current into time. Sometime they will ask calculate number of electron. So Abdullah, if they ask to calculate number of electron, then the Q is equal to NE. Sir, what is capital N? N for number of electron. N for number of electron. And E for elementary charge or charge of one electron. This is but a charge of one electron. It is formula number one. Then formula number two. Sir, voltage is work done per unit charge. So V is equal to V work upon Q. Work upon Q. Unit is volt. And formula number three, sir, V equal to IR. V equal to IR. Sir, V is the voltage, I is the current, and R is resistance, which we will study tomorrow. We haven't started the concept of resistance. We will discuss resistance tomorrow. So this is the summary of today's class. And now we are shifting to a sheet of past papers. And the name of the student is Abdullah Irfan. And it is electricity question sheet. And now the question number one on your screen. अभी अभी बेटा मैंने ये बात समझाई है। क्या सिमरा आप हमें बता सकती हैं वोल्ट is the unit of which physical quantity? Volt is the unit of which physical quantity? Sir, volt is unit of voltage, and the unit of voltage is work. Sorry, the formula of voltage is work done per unit charge. But Simra, what is the unit of work? What is the unit of work of Simra? Yeah, what is the unit of work? Joule. You are right. You are right. And what is the unit of charge? Coulomb. Then what is the answer? Because they are asking volt equals to what? Yeah, it is joule per coulomb. It is joule per coulomb. Okay. So it is your first proper question from your past paper sheet. Volt is the unit of voltage. Its formula is work done per unit charge, and its unit is joule per coulomb. Now question number two for Banin. Banin beta, you are given a graph and they are asking which electrical component graph is this? Filament lamp, fixed resistor, copper wire or thermistor? Ji beta Banin, I have taught you right now. Oh no, no, no. Yes, yes, you are right. You are right. Because I have not taught you thermistor. नहीं नहीं बनी तुमने सही बता दिया गलती से। हाँ हाँ सही बताया तुमने। सुनो भाई। ठीक है समझ। ठीक है भाई। अच्छा जी। अच्छा बेटा इन दोनों को बता दो। सिमरा बेटा दिस इज सिंबल ऑफ थर्मिस्टर। दिस इज सिंबल ऑफ थर्मिस्टर। Okay, and the resistance of thermistor is inversely proportional with temperature. When you increase voltage, then obviously current will increase. When current will increase, then thermistor becomes hot. And when thermistor becomes hot, then its resistance will decrease. And if resistance will decrease, then you can see the graph is a curve, and this curve is bending towards current axis. This curve is bending towards current axis. Okay, and this is the reverse graph of filament length, because you know in filament length the graph turning away from the current axis. Why? Because for filament, resistance is directly proportional with temperature. Sir, if you are studying length, filament length, for filament length, curve is bending away from current axis. And for thermistor, because this is a question of thermistor, Bunny's answer is right. Sir, for thermistor, the curve is bending towards current axis. हाँ बेटा सिमरा ये बात समझ में आती है फिलामेंट लैम्प का ग्राफ वी हैव स्टडीड एंड इट्स रिवर्स कॉन्सेप्ट is for thermistor because thermistor resistance is inversely proportional with temperature. Sir, why it is inversely proportional? I will explain you. Okay. But when temperature increase, the resistance of thermistor will decrease. When temperature will increase, the resistance of thermistor will decrease. Whereas for lamp, you know, this is the symbol of lamp, and for lamp, when temperature increase, its resistance increase. तो बेटा अब्दुल्ला ये बात समझने की जरूरत है कि अगर लैंप होगा ना बेटा लैंप होगा तो जब लैंप गर्म होता है तो रेजिस्टेंस बढ़ जाती है बट इफ देयर इज अ थर्मिस्टर इफ देयर इज अ थर्मिस्टर थर्मिस्टर गर्म होता है तो रेजिस्टेंस कम हो जाती है तो ये दोनों एक दूसरे के साथ उल्टे हैं अच्छा जी नाउ दिस इज आई एम आस्किंग सिमरा सिमरा बेटा कैन यू आइडेंटिफाई व्हाट इज दिस सिमरा बेटा व्हाट इज दिस यस दिस इज डायोड this is diode okay and if this is a diode then I have taught you the graph of diode few minutes earlier and I think the term diode is used yes so the term diode is given in this question okay but this is the diode you are given and now I am asking you what will be the graph of diode Simra what is the graph of diode it is D but D जब होता if voltage is along y-axis, sorry, x-axis. If voltage, low voltage, no current. Low voltage, no current. After a certain voltage, then there is a current. Okay. If voltage would be along x-axis. But in this question, sir, voltage is along y-axis. They have interchanged the axis. So at low voltage, no current. At low voltage, no current. And then current starts. Then current start. So the right answer is C because they have interchanged the current and voltage axis. They have interchanged the current and voltage axis. That is why the shape of the graph is changed. तो बेटा सिमरा नोट कीजिए if voltage is along x-axis then this is graph. If the voltage is along y-axis then this is graph. जी बेटा सिमरा is it clear? The answer is C. Okay. अच्छा जी and I think I should stop my class by this question because I will give few minutes with Abdullah.